Jain viewers, good morning to all. Welcome to AKGEC Digital School. My name is Pankaj Singh, Faculty of IT Department. Today I am delivering my video lecture on topic segmentation, that is a part of memory management. So let us start. So first of all, we understand what is the meaning of segmentation in general terms or in specifically regarding to the operating system. What is segmentation? Segmentation is another non-contiguous memory allocation technique. As we know that in operating system, as I deliver in my previous video lecture, one of the topic that is paging. Memory allocation is done in a basic two methods. First one is contiguous and second one is all things are done in a continuous memory space just like a array. Memory allocation for any process is allocated in a continuous form, just as we see in a array. And in a non-contiguous memory allocation, the allocation of a process is allocated under a main memory at a different address location. For example, we have 0 to, for example, address 0 is already occupied, address 2 occupied, likewise, and 3 also occupied. And we want to store a process that is of for example, of 4 KB. And we know that memory generally divided into frames that are fixed size of 2K, 2K, like that. And the size of process is 4K. So how will we store in a main memory? As we see, there is no 4 KB block in a main memory. So it will divide it into according to the frame size and it will convert into a 2K frames of 2. So it will be stored at a location 1 and location 4, whatever. So actual allocation is done in a non-contiguous form in this way. So what is the role of segmentation in a operating system? How it is differ from a paging, and what is paging concept? To understand all these things, we will take a brief look difference between paging and segmentation over here. As we know that paging and segmentation, both are memory management techniques, or we can say methodology generally used to allocate the memory space in a main memory or secondary memory. In paging, a program is divided into a fixed size frames. What it means here? For example, as I said in a previous example, if we have a program of 10K and the frame size is of 2K, then the number of frames required equal to 10 by 2. That means we required 5 frames. It is a static. All the frames will divided into a chunk of 2K and they will get the location in a main memory. And what is the basic difference between paging and segmentation? For example, we will take the same example here. If a program of 10 KB, but in this approach, a program always divided into a fixed size according to the size of frame as given in a question, or we can say the size of a main memory. It is the drawback of this. What is the drawback? For example, we have a program in which we have a main function along which we have a different procedures like functions. For example, we are performing A plus B and the part of a program lie within a over here A plus B. For example, the value of A will lie in a F1 and the value of B will lie in a F2. it is a programming, or we can say machine approach, in which we will not do any dynamic or as per user requirement division. It will divide the program into as the fixed chunk of 2K. So what is the drawback? The one part is lie in a F1 and second part will lie in a F2. But in a segmentation, it is done according to a logical division. What is logical division? Logical division is done according to the customer, according to the user requirement. How it will done? The first segment is make of just like main, procedure, functions, different symbols and tables we used in a program. For example, 10 KB, out of 10 KB, 2 KB of main, procedure is of 1 KB and function is of 5 KB and symbol consists 2 KB, right? But in this, all are divided into a fixed size. So it is a basic difference between paging and segmentation. So segmentation is a user approach, or we can say dynamic. It is a system approach, or we can say static. It is fast as compared to the segmentation, but the problem is that for fetching the same functions, we will go to the 2 frame locations or 2 address location in a machine. So now hopefully it is very clear to all of you what is the basic difference between paging and segmentation. So now come to the how segmentation is done in a machine or for a program. Here we have an example of a program in which program is divided into a 5 segment. What this segment will consist or what they will contain, just like segment 0 will contain the main program. Likewise, segment 1 will contain library functions. Segment 2 will contain stack. Segment 3 will contain procedure. Segment 4 will contain the procedure 1. That is the logical division of a program. All the procedure related to the procedure 1 will lie into a segment 4. Similarly, all the procedure related to the 2 will lie in a segment 3, and all the functions related to the main program will lie in a segment 0. As I said in a previous PPT, the size of this segment will vary. That is not fixed as like in a paging. That may be of 2K, that may be of 5K, that may be of 1K, that may be of 2K, that may be of 1K. That is total 10K, as I take the example in a previous PPT or in a differentiation between paging and segmentation. So hopefully it is very clear here. The segmentation is a dynamic approach in which all the programs or is divide according to their logical division, or we can say in that part logical division is performed. But in paging only static division is done. That doesn't matter either in a segment 0 all main programs features and function will lie or not. Now the major part to fetch the physical address from logical address, as we know that computer always call logical address and that will convert into a physical address. So how it will done in a segmentation, we will understand in a next slide. So here we repeated many times segmentation. So how this is done or how this data will maintain, that is done by the help of segment table. What is segment table? I read here some few points. Segment table is a table that stores the information about each segment of the process. It has 2 columns. What these columns? One, segment name and offset bit. It consists two field. In abbreviated form, it is written as S and D. So first column store the size or length of the segment, and the second column store the base address. At what address it is stored in a main memory. So here one thing is also discussed here. I will go to the previous slide. As I said, the size of main memory is of 2K. So what here means that this segment is, for example, segment S0 is stored in a location of 200, that is the base address, and the limit, that is the most important part of segmentation. Every program or segment that is stored in a main memory, it have two fields. One is segment name or address, and the second one is limit. Up to which address or up to which location segment 0 is lie in a main memory, that is the most important. For example, the limit of segment 0 is 50. That means within a main memory, segment will lie, S0 will represent at a 200 and the max will go to the 250. That is the basic representation. Likewise, other segment also stored in a same way. So here segment name S0, S1 up to S5 if we take the previous example. And the all segment have a different range to store their content in a main memory. For example, segment 0 offset bit will represent here its limit, that is 500 or 50, whatever we transfer here. Then segment table is stored as a separate segment in a main memory. After that, segment table base register store the base address of the segment table. So these are the content within a segment table. Now we have an example of the same. Here, as I said in a previous slide, limit indicate the length and size of the segment. For example, I repeat here, segment 0 will start from 200 and go up to the size of segment is limit is 50. So the next up to 250 address S0 will lie, and after that the next segment may or may store in a main memory. After that, the major concern is here, CPU always call logical address and the content is stored in a main memory according to the physical address. So major concern is here how to convert segment table address into a physical address. As we see in a previous PPT, logical address consists what? The segment number and the limit, or we can say offset bit. A physical address is needed to access the memory, main memory, and we also know that logical address always called by the CPU. So how this conversion is done, as we also read about it in a paging, but there is a one more parameter is also checked here, that is the limit of a segment. Because the limit is vary here according to the size of the segments, but in case of paging, the size is fixed. That's why measuring or comparing the limit is not required. Here we see an example. For example, what the segment table will consist. With this example, all things will clear. As we see here, we have a segment number. For example, segment 0, segment 1, segment 2, segment 3 and segment 4. Here, these are the base address. That is represented as BA, base address. What is the base address of segment 0? That is 1500. What the meaning of limit? Means it will contain 1500 lines, or we can say address. So segment 0 will start from the 1500 and it will contain this limit. For example, when we call a address, when we call a segment, it limit also specify up to which CPU want to read the content of a segment. We will understand it into a next PPT. Likewise, the base address of segment 1 is 6300 and the limit of this segment is 500. So how it will calculate? We will add the limit into the base address and it will go up to the 6800 and that is 500. Likewise, segment 2 start from, or the what is the base address? That is 4300 and it's go up to the 400, means the limit. We will add the 400 into 4300, that will go up to the 47. And likewise, all base address is mapped into a main memory in this method. So that is the representation or storing of a detail of a table into a main memory. And the major concern is arise here, how to fetch the content of main memory to the CPU, because CPU always call the logical address and the content is stored in a physical address. To perform this conversion, we will use here a detailed flowchart that will help out all these things. Here we have a flowchart, or we can say the block diagram, how to convert a logical address into a physical address. As I said, CPU call the logical address. What logical address consists? The segment number and the offset bit. For example, if we will take the example of the previous one, if we will take the example of segment 1, okay, what is the limit of segment 1? That is 500. For example, CPU call segment 1 and the offset range is 200. Okay, what is the meaning of 200? Means up to 200 CPU want to read the lines of a segment 1. And what is the limit of segment 1? That is 400. Sorry, that is 500. Max is 500. So within a program there are lines from 0 to 500 and CPU want to read value of segment 1 from 0 to only till 200. So how the base segment table will help out all these things? The segment number, because the segment number details is stored in a segment table. We have here segment number 0, 1, 2, 3, 4. So it will go to find the segment number from the segment table. As we go here, segment number 1, that is stored at 6300. Sorry, the base address is of 6300. So first the pointer will go to the at the 6300. Up to which level the content of S1 will read, that's depend on the offset bit as given in a logical address. What is the offset bit? That is 200. So it will compare the range of offset bit with the limit of the base address of a given segment. What the mean here? What is the comparison here represent? It will compare the 200 with the limit. What is the limit of segment 1? That is 500. I overwrite it here. So it will check if it is less, or we can say equal to this address, that's fine. If for example the offset bit is 800, that will compare with the 500. The trap find out that this is not the address of a segment 1, that will lie into a maybe another segment. So in this case, this address or program will not read out, and it will terminate. But if the value of offset bit is less than or equal to the limit of a base address, then it will pass in a yes state, and it will read the content 6300 to the up to 6500, and the max limit it contains, that is 6800. That means that lie within a table, or we can say all the content is valid, and the CPU will fetch the program features or whatever he required to execute the program. By this way, segmentation is executed within a machine. Hopefully it is very clear to all of you. These are the steps as I told you with the examples. It will contain the same thing. What is the meaning of offset bit as we compare, that is equal to or not equal to. Thank you. You will meet in a next video lecture.